Cubic Functions, Mathematics Grade 12, Paper 1. Here is another example of an examination question on cubic functions that can help us revise a few concepts. Now, let's have a look here. The graph of f and g are given. F of x is equal to x cubed plus 1 and g of x is equal to 2x minus 2. A and B are the x-intercepts of f and g respectively. C is a point on f and D is a point on g such that CD is parallel to the y-axis. CD lies to the left of the y-axis and the graph intersects. They intersect at point E. Determine the following. We want to find the coordinates of point A. Before we answer the questions, what are the general ideas that we must have for us to be able to get this right? So question number 1, we notice that point A is the x-intercept of the function. And for you to find the x-intercept, you must equate f of x to 0 and solve for x. This will give us the answer for number 1. The answer for number 2, determine the equation of the tangent of f at point A. For you to determine the tangent to a graph, you need two pieces of information. Number 1, you must determine the gradient of the tangent. You need to know what is the gradient of the tangent. The gradient of the tangent comes from the derivative. So you differentiate the function and in the derivative you substitute x with the x value at which the tangent is touching the curve. So we need the gradient of the tangent, and for that we're going to use the derivative. Then another piece of information that you need the coordinates of the point of contact. Where is the tangent touching the curve? So you need the coordinates of the point of contact. These two pieces of information can help you determine the equation of the tangent. Then the third question, we must find the value or the possible values of x for which CD is equal to 4. In general, we know that CD, which is the length of a line, if the line is vertical, we subtract the top graph minus the bottom graph. So in this case, it's going to be f of x minus g of x. Then after that, we simplify this to simplest form. Then secondly, we differentiate the expression that we got, and after differentiating we equate to 0 to get the value of x that can lead us to the maximum or minimum value of the line. So the x value that we get from here, we substitute it into the expression for CD, and that will give us the length of the line. I'm speaking in general here. But for this particular case, the question number 3, the value of CD is given. So what we are going to do is, we are going to say 4, which is CD, is equal to f of x minus g of x. Then we solve the equation to determine the required value of x. Then question number 4, f of x is greater than g of x. Generally, we are saying that the graph of f is above the x-axis. It is on the positive side. Where is it happening that the graph of f is above the x-axis? That is the answer we need for 4.1. Number 4.2, this is the second derivative. This means the second derivative, which is a linear function that comes from differentiating this, is a positive one. Then the last one, if you multiply the two graphs, the answer is positive. So we have made a video on this one as well. Look for sections. Look for sections or a section where the signs are the same. You must find somewhere where the signs are the same, because if you multiply a negative and a negative, you get a positive. If you multiply a positive and a positive, you get a positive. So for f of x multiplied by g of x to be positive, both of them must be positive, or both of them must be negative. So in a summarized form, these are the ideas that are being tested by this examination question. So the moment I look at an examination question, I must be able to think of ideas that I can use to answer that particular question. Let us have a look at the answers to these questions. Question number 1, find the coordinates of point A. We notice that A is the x-intercept of the function. To find the values or the coordinates of the x-intercept, we equate f of x to 0 and solve for x. So equating f of x to 0 and solve for x, giving us x is equal to -1. Just for interest's sake, this is a cubic function. So if you go back, take your memory back to grade 10, you will remember that in grade 10, we did cubic expressions as sum and difference of cubes. So this can be factorized as a sum of cubes into x plus 1 factor of x squared minus x plus 1. Then from here, if this is equal to 0, then we can get x is equal to -1 from the first bracket. This other one has non-real roots, and hence the graph is crossing the x-axis at one point, which is point A. So the coordinates of point A are -1 and 0. Then question number 2, we want to determine the equation of the tangent to the graph at point A. For you to be able to do this, you need two pieces of information. You need the gradient of the tangent, and apart from the gradient of the tangent, you need one point. You need the coordinates of a point where the line is touching the curve. Now let's do the first calculation. How do we find gradient? From what we have done so far in calculus, we know that the gradient is equal to the rate of change. So basically the gradient is the derivative of f of x, which means I must differentiate f of x and find the derivative. After differentiating x, I substitute x with -1. So x is equal to -1, and this -1 is coming from point A, because at point A, that is where the line is touching the curve. The x value of point A, which is -1, is what we substitute into x in the derivative to determine the gradient at x is equal to -1. So for this particular question, the gradient is equal to +3. Then after calculating the gradient, we can use the general form of the linear equation, y is equal to mx plus c. And we know that in this equation, m is the gradient. And we have already calculated the gradient. Our gradient is equal to 3. So we're going to put 3 in the position of m. Then c is the y-intercept of the function. Now we don't have the y-intercept in this case, so we're going to calculate it. To calculate the value of c, we substitute coordinates which are on the line. And the coordinates that we are using here are the coordinates of point A. That is the point which is on the line. We can substitute these coordinates to determine the value of c. and that will complete your equation. So going forward, we have 0 is equal to 3 times negative 1. Now in this equation, 0 is the position for y and negative 1 is the position for x. Then this one is m. We are calculating c. So if we do those calculations, we are able to see that c is equal to a positive 3, and therefore we can now complete the equation of the tangent. So the tangent equation is y is equal to 3x plus 3. That is how to determine the equation of the tangent. The third question, we need to find the values of x for which the line CD is equal to 4 units. That is what we need to do. Now, in general, I always emphasize that when you are doing maths, look at the general part of it so that you can apply the same information even in a new situation. If you are given the length of a vertical line, we can find the length of the line by subtracting the top graph minus the bottom graph. So let's say in this case, we want to find the value of line CD. Then we can say CD is equal to C, which is the first letter, is on the graph of F. Therefore, it's going to be f of x, and D is at the bottom. It's always the top minus bottom. So it's going to be f of x minus g of x. This is the expression that must give me the length of line CD. Then you simplify this expression to simplest form. The value of f of x is x cubed plus 1. The value of g of x is equal to 2x minus 2. You simplify this equation until simplest form. So after simplifying to simplest form, what you get there is the length of line CD in terms of x. In some examination papers, they can ask you to say, what is the length of the line CD in terms of x? The length of the line CD in terms of x is equal to x cubed minus 2x plus 3. Now, after determining the length of the line, at the maximum or minimum of anything, at the maximum or minimum of anything, the derivative is always equal to 0. So that means after determining f of x minus g of x, we differentiate that expression to 0 and then solve for x. The x value that we get, we bring it back into the expression for the line. So I'm going to get the value of x, and the x I get here, I bring it back into the expression for line CD and substitute into x to find the units or the length of the line CD. That is how these kind of questions are treated in general. You subtract the top graph minus the bottom one. Simplify the equation to simplest form, differentiate, equate to 0, and solve for x. When you get x, you go back to the expression before you differentiated it and substitute the value of x to determine the maximum or minimum length of that line. Now, in this case, we are not going to do that because that is not what the question is asking us. I am just explaining the idea behind this kind of question so that should we be requested to do something like that, then we must be able to do so. In this case now, we are told that CD is equal to 4. So we still have to subtract CD is equal to f of x minus g of x. And then we simplify the expression. but we are not going to do the differentiation process because the length of the line is given. So here, this first part of my expression, this is f of x. Then the second part of my expression, this one here, this is g of x. So this is f of x minus g of x is equal to cd, and cd is equal to 4. Now that's how I created that equation. So we carry on and solve it and simplify the equation to standard form. Now it is x cubed minus 2x minus 1. I am solving a cubic equation here. Therefore, I need to bring back the ideas of factorizing cubes. I can use the factor theorem. I may need the long division. I may need the synthetic division, whatever method you are comfortable with. So these are simple numbers. It must be very much easy to do. So we check one number that can be substituted into x to give 0. In this case, it's -1. If you put -1 in place of x, the answer is equal to 0. So it follows that if this was a function, we can safely say f of -1 is equal to 0. It means x is equal to 1, and x is equal to -1 gives us x plus 1 as one of the factors of the expression or the equation. Now we can factorize using that -1 using any method of our choice. So in this calculation, we are using the synthetic method. We have explained this method in one video, but let's just quickly recap just to remind you where these numbers are coming from. The first value here, this is the value of x. X is equal to -1. That is the number that we have tested in the previous step. X is equal to -1. Then these other 1, 2, 3, 4 numbers, they are the coefficients of the cubic function that we are factorizing. The coefficient of x cubed is 1. That's where we get the first one. Now, there is no x squared here. So that means we have 0x squared. And the coefficient of x squared in that case will become 0. The coefficient of x is -2. The last term, which is the constant, is -1. That's where the 4 numbers came from. Now to do the synthetic division, we bring this number 1 down. Then you multiply it by the value of x minus 1 times 1. The answer that we get, we write it under the next column. And then we add these two numbers again to get -1. -1 times -1, we get +1. Then we add this to get -1. We multiply again -1 times -1. We get a +1, and we add these numbers. The answer is 0. Now, after that, the numbers that we get, this is synthetic division, is now complete. We need to know what these numbers mean. This one here is ax squared, so a is equal to 1. Then the next one is bx squared, bx, b is equal to -1, and the last one is equal to c. So the value of a, b, and c are what we get from the 3 numbers after the synthetic division. Now we can put our factors in brackets. So the first one is x plus 1, which has come from the first value, x is equal to 1, that we were using. And these other 3 numbers, they give us this quadratic factor. Now, to complete our answer, we need to solve it. The one part of the expression cannot be factorized. Therefore, we may apply quadratic formula or completing the square. And in this case, we have used the quadratic formula. That will give us the values of x. X is equal to -1, or x is equal to 1.62, or x is equal to -0.62. So the values of x from this expression, the -1 is out because it is the -1, or we have got -1. It is the coefficient, the x-intercept at point A. also from our previous calculation. So there is -1 here. Then the other value is -0.62. So this is -0.62. Now our line is on the negative side. So the two numbers that we may need for this question, which the question is asking for, we can make a conclusion and say that therefore x is equal to -1 or -0.62. These are the two answers for our equation. So these are the two values of x for which the line CD may equal to 4. So the question is asked in different ways. If they say to you, what is the maximum or minimum length of line CD? You subtract top graph minus bottom graph, simplify, differentiate, equate to 0, solve for x. If they give you the length of the line, like in this case, subtract top graph minus bottom graph, you don't differentiate anymore. You equate that difference to the value that is given, and that will allow you to calculate the answer that is required. That is my question number 3 for 7 marks. In this particular examination paper, it was 7 marks, and definitely that's a lot of marks. All right, the last question, number 4. F of x is bigger than 0 or f of x is positive. Now, we are looking for the section of the graph which is positive. The positive part of the function is that part of the graph which is above the x-axis. And from this grid, we can see that from point A, the graph of f is positive on the right-hand side. So we are looking for the sections where the graph is positive or where the graph is above the x-axis. And that is happening from A going to the right. The coordinates of point A are -1 and 0. So we can say the answer to this question is from -1 up to positive infinity, or x is greater than -1. That is the answer for number 4.1. Number 4.2, we need to remember that if you differentiate a cubic function, you get a quadratic expression. So f of x is equal to x cubed plus 1. Differentiated, this gives us 3x squared. Then differentiated again, this gives us 6x. Now the gradient is a positive here. The line is passing through 0, 0. So from point 0, 0 to the right hand side, we will be having a positive function. So that means the answer to this question, where the second derivative is positive, is on the right side of 0, from 0 to infinity, or we can say x is greater than 0. So this can be written in two ways. We can also say x is greater than 0, x is an element of 0 up to positive infinity, or we can say x is bigger than 0. Then number 4.3, we want to find sections on the graph where the signs for the two graphs are the same. They must both be positive or they must both be negative. The idea comes from integers, because if you multiply a negative times another negative, the answer will be positive. And this product here is bigger than 0. Bigger than 0 means it is positive. And for it to be positive, we must multiply a negative times another negative, or we must multiply a positive times another positive. So put in short, we must find the section or sections on the graph where the graphs are having the same signs. They are both negative or they are both positive. Now, if we look at our graphs, this is check from point A going to the left. This is the graph of f, it is negative. This is the graph of g, it is negative. This is from negative infinity up to -1. Within this space, both graphs are negative. If we multiply a negative times another negative, the answer is going to be bigger than 0. So that is one of the answers I need for this question. So I can say x is an element of negative infinity up to negative 1. From negative infinity to negative 1, both graphs are negative. Or I can say x is less than negative 1. Then carrying on, if we look at what's happening from point A up to point B, in between point A and point B, one graph is positive, but the other one is negative. They have different signs. The coordinates of point B are 1, 0, coming from the x-intercept of G. Now, if we were requested to find the values of x for which f of x times g of x is less than 0, that means it's negative, then we were going to take the values of x from this middle space here, from point A up to point B, because from A to B, the graphs have different signs. That's x is an element of negative 1 up to positive of 1. So in this case, we want sections where the signs are the same. Look at what's happening from B going to the right-hand side. G is now positive. So this is a positive G, and also we have got a positive F. That is from point B going to the right-hand side. So that is the next answer for us. We can say from B, which is 1, up to the positive infinity. The signs for the two graphs are the same. Or we can express it as x is less than 1. These are the answers for question number 4.3. So the whole question has been answered. A number of concepts have been tested here. It is absolutely necessary to have a complete picture of what the question is talking about so that you can learn the general part of it in such a way that if you open up another different examination paper, you should be able to answer it. That's Cubic Functions, Grade 12, Mathematics, Paper 1.